Hey guys, this is Mr. Bennett. This is Unit 5. We're talking about the periodic table, and this is video 5-2, groups and valence electrons. Now, in our last video, we talked about the periodic table. We talked about the idea that it's organized around the characteristics of elements, meaning that if an element has a similar chemical property to other elements, then they'll be in the same group, family, or column. Okay. We didn't explain why though. The why goes back to an idea from last unit, something we call valence electron configuration. Let's take for example sodium. Sodium has 11 electrons. So if we were to write its electron configuration, it would be 1s2, 2s2, 2p6, 3s1. Now valence refers to the outer energy level. So if we were to look at this, its innermost energy level is the first energy level. That's the 1. Its second energy level is here, and its outer energy level is the third energy level. It has 1 electron currently in the third energy level within that s sublevel. So we would say that it has 1 valence electron in the s of the third energy level. Now, the reason why valence are important is because they determine chemical reactivity. So if you have similar valence electron configurations, that means you have similar chemical properties or chemical reactivity. So going back to sodium here, sodium we just said its valence configuration is 3s1. If we were to look at lithium, lithium's valence would be 2s1. Hydrogen would be 1s1. Potassium would be 4s1. Rubidium would be 5s1, and so on. Go all the way down. This would be 6s1, 7s1. So they all have 1 electron in their s sublevel. Turns out that these chemicals react similarly when it comes to chemical reactions. And if we were going to the second row or second column, this guy here would be beryllium, would be 2s2, magnesium would be 3s2, and we could go down the list, 4s2, 5s2, 6s2, and they all behave in a similar way chemically because they all are ns2. Okay, same thing for group 13 or 3a. It's going to look like this. All the elements in group 3a or 13 behave similarly because they have ns2 and p1. So we can simplify this. I know that sublevels and energy levels gets a little confusing, especially if we're talking about them in multiple energy levels. So let's make it simpler. If we look at group 1, okay, so all the way down this whole section here, okay, I know that's not pretty, but anyhow, so if we look at group 1 or group 1a, again they have 1 electron in the s, so we would say that it's 1 electron in the s sublevel, 1 valence electron. Group 2 has 2 electrons in the s sublevel, which means it has 2 valence electrons. Okay, we go on to group 13 or 3a, 2 here, 1 here, that means 3 valence electrons. Group 14 or 4a, we have 2 electrons here and 2 electrons here, so that's 4 valence electrons. Now if you haven't picked up on it yet, check this out. Group 1 and group 2 coincides with their valence electrons. But then we jump to group 13. Okay, we don't have 13 valence electrons, but if we look at the number next to the A, that does coincide, right? 1a was 1 valence, 2a was 2 valence, 3a was 3 valence, 4a was 4 valence, so that means 5a is 5 valence electrons, 6a is 6 valence electrons, 7a is 7 valence electrons, and 8a is 8 valence electrons. Okay, we can double check this here. Notice s plus p gives us 5. S plus p gives us 6. S plus p, or 2 plus 5, gives us 7. So when we're looking at the valence electron number, there's 2 ways you can do it. You look at the number next to the A, or you take S plus p. Either way will give you the valence electrons. Okay?